Okay, so once again, I welcome you to another class. Okay, in today's class, we are looking at the topic stoichiometry. Stoichiometry is one aspect of chemistry that have to do with the calculation involving different things. When you talk about calculation in chemistry, you're talking about stoichiometry. So it has a lot of it's cut across different things. In today's aspect of stoichiometry, we're talking about mass to mass. You have to calculate where you have the mass of one element given, and you have to use to determine the mole of another element. Then you have mass to that's that mass to mole. What I just said now is mass to mole. Then there's mass to mass, where you use the mass of one of a given element to calculate for the mass of another element. Then you have mass to volume, the same thing. You use that the volume of a given element to calculate the mass of another element, or the mass of one element to calculate for the volume of another element. Then you have mole to mole, and then mole to volume. These are some categories of stoichiometry. There are other aspects of stoichiometry that have to also do with acid, base, titration, and all those things that involve acid and base operation. Now, how do we solve stoichiometry? One of the ways to solve a problem that involves stoichiometry is number one, get a balanced chemical equation for the question. A balanced chemical equation will give you an hint because according to the law of conservation of mass, that state that you can't create energy, you can't destroy energy, but it is converted from one form to another. So the law of conservation of mass tells you that the mass of the reactant must be equal to the total mass of the product. So if you have two reactants, if you add up their mass, it must be equal to that of the product. The same, so number you have to balance the chemical equation. That's the first one. Then number two, there's what we call theoretical masses, volumes, and moles. From your equation, you have to calculate the theoretical masses, which have to do with the molar mass of the reactant. Take note, the molar mass of the reactant that is involved in the process. This takes us to that number three, the question focus. When you look at the question, what does the question demand? What does the question require? So if you focus on the question may demand maybe one particular, in the midst of the so many reactants present in that particular equation, you may just need one or two of those species, maybe one reactant to one product. This takes us to number four, relating the theoretical masses, volume or moles to the actual or given masses, volume or moles to determine the solution of the problem. What does this mean? If, for example, I tell you that 2 gram of hydrogen was used to produce 4 gram of water, that is a statement. Or rather, maybe I said, if I say calculate the mass of water that will be produced from 2 gram of hydrogen. Normally, the balanced chemical equation for the production of water between hydrogen and oxygen is H2O. So assuming I say you should calculate the mass of water that will be produced from 2 gram of hydrogen. Take note of the requirement now, 2 gram of what? Hydrogen. Now we have to look at the equation. The equation here is not balanced. So in balancing the equation, this is 2 hydrogen, this is 2 hydrogen, but the oxygen here is 2. So to balance the equation, we need 2. I think I'll also make a video. In my next video, I'm going to teach you how to balance a chemical equation. So but from what we have here, when you balance these 2 equations, you see that the equation is balanced already, but you have, sorry, it's not balanced because hydrogen is 4 here, so we need a 2 here. Now from this equation, if you look at this is equation, balanced already. The theoretical mass based on the requirement is hydrogen and water. So the question do not demand oxygen. Though the equation demands, but the question do not demand. That's why I say question focuses. You have to know what the question focuses on. So based on this thing, these two, according to the equation, we have 2 H2 giving what? 2 H2O. This is the process. Now we have to get the mass to mass. You know that the ink, hydrogen is 1, oxygen is 16. So let's get the mass of the reactants and the product. So we have 2 brackets 1 times 2, giving you 2 brackets 1 times 2 plus 2 plus 16. In my previous video, I've taught you how to calculate relative atomic masses as well as molar mass, relative molecular mass as well as molar mass. You can check my previous videos for that. Now, this will give us 2 bracket 2, giving you 2 bracket 2 plus 16. So everything here, let me create space. Now, everything here, when we bring it up here, we have 4 gram of hydrogen, gram of hydrogen according to the question, giving us 2 times 18, which so 4 gram of hydrogen give us come in, give us 36 gram of water. But the question said, what mass of water will be produced by 2 grams of hydrogen? So we see using the method, so in 2 grams of hydrogen will give us X. When you cross multiply, in this case, you cross multiply, you multiply, you have 4X equal to 2 times 36. Finding the value of X, you have 2 times 36 will give us 72 over 4. When you divide this, you are going to have basically 4 into 72, you have 1 and 3. So you have therefore 13 gram of hydrogen will be equal to 13 gram of water will be produced will be produced sorry will be produced by 2 gram of hydrogen. So this is just a simple way by which you can solve stoichiometry. And I believe that I will calculate more in my next videos. I'll also be again bringing in more some questions that will enable us to do more on stoichiometry. So this is just the summary I just brought out now in order for you to understand how to use this 4 basic methods to get stoichiometry easily. Thank you very much. Bye.